Welcome to Science for Sleep, where wonder and calm meet. Each night we drift through galaxies, oceans, and mysteries of the natural world, not to startle, but to soothe. So, take a deep breath. Let curiosity slow your thoughts, and fall asleep to the sound of discovery.
The biggest secret of our Milky Way, the river of stars, there is nothing you need to do right now. Nothing to solve, nothing to remember, and nowhere you need to be, except right here, in this quiet, comfortable space. For as long as humans have looked up at the night sky, we have seen this celestial river. We did not always know what it was, but we knew it was special. We gave it names born of poetry and myth. To the ancient Greeks, it was the milk of a goddess, spilled across the heavens. In China, it was the Silver River, separating two celestial lovers. In the Andes, it was a river of souls, a path for spirits to travel. Every culture saw it, and every culture felt its wonder. It was a constant, a landmark in the cosmic ocean, a reminder that the universe was grander and more mysterious than our small world below. But the greatest revelation, the most profound shift in our understanding, came when we realized that we are not just looking at the Milky Way, we are looking through it. We live inside this river of stars. That beautiful, hazy band of light is the view from our small, quiet home, looking into the dense, crowded heart of our own galaxy. Imagine that for a moment as you continue to float, weightless and calm. You are not separate from that beautiful river of light. You are a part of it. Every atom in your body was forged in stars just like these. You are, in the most literal sense, a child of the Milky Way. Let that thought hold you. Like a gentle embrace, you belong here. You are home. Our galaxy, this vast, spinning island of stars, is almost unimaginably large. If you could travel at the speed of light, the fastest speed possible, it would still take you 100,000 years to cross from one side to the other. 100,000 years of constant travel just to span the diameter of our home. And within this vast structure, there are as many as 400 billion stars, 400 billion suns, for every person who has ever lived on Earth. There are dozens of stars in our galaxy alone. Some are giants, burning with fierce blue light. Some are dwarfs, glowing with a soft red warmth. And one of them, one very ordinary, very stable, yellow star, is our Sunday. Our Sunday. And our Earth and you are all drifting together on a slow, majestic journey through this river of stars. We are not at the center of it all. We are not in a place of cosmic importance. Our home is in a quiet, peaceful suburb of the galaxy, a place that allows for the gentle, uninterrupted flourishing of life. We live in a spiral arm, a gentle, curving lane of stars and gas and dust, called the Orion Spur. It is not one of the grand, major arms of the galaxy, but a smaller, more local feature, a quiet side street in the cosmic city. From here, we are about 26,000 light-years away from the galactic center, far enough to be safe from the chaos and radiation of the galaxy's core, but close enough to be surrounded by the beauty and the raw materials of creation. We are in a perfect place, a Goldilocks zone, not just for our planet around our Sunday, but for our solar system within our galaxy. And from this perfect, quiet place, we are all on a grand journey. Our entire solar system is orbiting the center of the Milky Way. We are moving at a speed of over 200 kilometers every second, but the circle is so vast, so immense, that it takes us about 230 million years to complete a single orbit, one galactic year. The last time our solar system was in this same spot, dinosaurs were just beginning to walk the Earth. The time before that, the world was a barren landscape of rock and ocean. with life just beginning to stir. This is the rhythm of our galaxy, slow, patient, and immense. A rhythm that you can feel in your own slow, steady breathing. Breathe in and imagine the slow, graceful turn of the spiral arms. Breathe out and feel yourself drifting along with our Sunday on this ancient cosmic journey. Everything you see in the night sky, every star, every constellation, is part of our local neighborhood. They are our neighbors in the Orion Spur. Fellow travelers on this grand orbit, we are all moving together, a family of stars, through the quiet, beautiful darkness. But what is the shape of this home we live in? For centuries, this was one of the greatest puzzles in astronomy. How do you map a forest when you are standing in the middle of it, surrounded by trees in every direction? How do you understand the shape of a city when you can only see down your own street? We live inside the Milky Way's disk, a flat, spinning plane of stars, gas, and dust. When we look up at that milky band of light, we are looking into the densest part of that disk. When we look away from it, we are looking out into the emptier space above or below the disk, where the stars are fewer and farther between. Astronomers became cosmic cartographers, patient detectives of light and shadow. They couldn't step outside the galaxy to take a picture, so they had to map it from within, piece by piece, using every clue the universe would give them. They used radio telescopes to listen for the faint hiss of hydrogen gas, the most common element in the universe. Hydrogen gas clouds trace the shape of the galaxy, like fog tracing the curves of a coastline. By mapping these clouds, astronomers began to see the faint outlines of vast, curving structures, the spiral arms. They used infrared telescopes, which can see through the dense clouds of dust that block our view. Dust that is opaque to visible light becomes transparent in the infrared. It was like having X-ray vision, allowing us to peer through the walls of our own cosmic house and see the structure within, slowly, patiently. Over decades of meticulous work, the picture emerged. Our Milky Way is a barred spiral galaxy. At its center is not a sphere of stars, but a dense, elongated bar, like a glowing cosmic spindle. And from the ends of this bar, the great spiral arms sweep outward, curving gracefully through space. There are 4 major arms, of vast rivers of stars and gas, where new suns are being born, and our home, the Orion Spur, is a smaller bridge, connecting 2 of these grander arms. Imagine it now, a celestial pinwheel, 100,000 light-years across, spinning slowly in the darkness. A beautiful, intricate structure of light and dust and gravity. And you are living on a tiny, blue speck of dust in one of its quiet, gentle arms. But as astronomers mapped our galaxy with greater and greater precision, a new mystery began to surface. A secret, hidden in the very motion of the stars. A puzzle that would change our understanding of everything. It began with a simple observation. The galaxy is spinning, but it is not spinning like a solid object, like a record on a turntable. In our solar system, the inner planets move faster than the outer planets. Mercury speeds around the Sunday, while distant Neptune moves at a slow, leisurely pace. This is how gravity works. The farther you are from the central mass, the slower you should move. Astronomers expected to see the same thing in our galaxy. The stars near the center should be moving quickly, while the stars at the outer edge, far from the dense core, should be moving much more slowly. It made perfect sense. But that is not what they found. When they measured the speeds of stars at the galaxy's edge, they were stunned. The stars were moving far too fast. At those speeds, they should be flung off into intergalactic space, like children letting go of a merry-go-round that is spinning too quickly. The gravity of all the visible stars, all the gas and dust we could see, was not nearly enough to hold them in their orbits. And yet, they were not flying away. They were held. They were bound. They were orbiting peacefully, as if in the grip of some immense, invisible force. Something was wrong. Either our understanding of gravity, the fundamental law of the cosmos, was wrong, or there was something else out there, something we couldn't see. A huge amount of mass spread throughout the galaxy, holding it together with its invisible gravity. This was the first whisper of the biggest secret of our Milky Way. The secret that what we see, the beautiful river of stars, the glowing arms, and the bright core, is only a tiny fraction of what is actually there, the heart of darkness. As we travel, the stars around us begin to change. Here, in our own spiral arm, the stars are like scattered jewels on dark velvet, with plenty of quiet, empty space in between. But as we drift inward, the spaces begin to shrink. The stars grow closer together. The darkness becomes less empty and more crowded with light. We pass through shimmering clouds of gas and dust, vast, colorful nebulae where new stars are being born. We see clusters of brilliant, young, blue stars, burning with a fierce, youthful energy. We see ancient red giants, swelling and glowing like cosmic embers. The sky behind your closed eyelids is no longer just black with points of light. It is a rich tapestry of color and texture, pinks and purples, blues and golds, all swirling together in a slow, silent dance. And the light is growing brighter. A soft, golden glow begins to fill your awareness. It is the light from the galactic bulge, the dense, spherical heart of our Milky Way. Here, billions upon billions of stars are packed together in a space only a few thousand light years across. They are older stars, ancient suns that have been circling the core for billions of years, their light blending together into a single, warm, radiant hum. It is beautiful, it is majestic, and it is powerful. But we are not stopping here. Our journey takes us deeper still, through the golden haze of the central bulge, toward the very heart of the heart, point zero, the gravitational center of our entire galaxy. As we get closer, something strange begins to happen. The stars are moving with a frantic, impossible speed. We see them whipping around an invisible point in space, like planets in a celestial dance on fast forward. Some of them complete an orbit in just a few years, traveling at thousands of kilometers per second. What could possibly have such a powerful grip? What could command such loyalty from these massive suns, forcing them into these tight, rapid orbits? The gravity required to do this is immense. It would take millions of stars packed into a tiny space. But when we look with our eyes, with our telescopes, we see nothing. There is no great star. There is no massive cluster. There is only darkness, an empty point in space, around which the universe seems to pivot. This is the heart of the mystery. This is the secret at the center of our galaxy. For decades, astronomers watched these frantic stars. They tracked their paths with painstaking precision, year after year, mapping their orbits, calculating their speeds. The work was slow, patient, and meticulous. It was led by two teams of scientists, one led by Andrea Ghez, and the other by Reinhard Genzel. They were in a quiet, noble race to prove what they all suspected. The evidence became undeniable. The orbits of these stars could only be explained if they were circling something incredibly massive and incredibly small, something with the mass of 4 million suns, all packed into a space smaller than our own solar system. There is only one thing in the universe that fits that description: a supermassive black hole at the very center of our galaxy, our home. There is a black hole. Its name is Sagittarius A asterisk, pronounced Sagittarius A star. Let that name rest in your mind. Sagittarius A asterisk. It is not a monster. It is not a villain. It is a fundamental part of our galaxy. It is the anchor. It is the heart. For a long time, we could only infer its existence. We could see its effect on the stars around it, but we could not see the object itself. How do you see something that consumes light? How do you photograph pure darkness? But recently, using a network of radio telescopes spread across the entire Earth, a telescope the size of our planet, astronomers finally did it. They captured the first ever image of Sagittarius A asterisk. It is not a picture of the black hole itself, but of its shadow, a perfect circle of darkness, surrounded by a glowing ring of superheated gas, swirling around the edge of forever, like water circling a drain. It is a breathtaking image, a confirmation of a reality that is almost beyond comprehension. A quiet, dark circle at the heart of a river of 400 billion stars. But what is a black hole? The name itself sounds frightening, a hole in the fabric of space. But let's not think of it that way. Let's think of it as a place of ultimate peace, a place of ultimate stillness. Imagine the fabric of space and time as a soft, flat sheet of silk. A star, like our Sunday, is like a small marble placed on that sheet. It creates a gentle dip, a small curve, and planets, like our Earth, roll around in that gentle curve. That is gravity. Now, imagine something much, much heavier, a bowling ball. It creates a deeper curve, a steeper well. And now, imagine something with the mass of 4 million suns squeezed into a point smaller than a grain of sand. The curve it creates in the fabric of space is no longer a gentle dip. It is an infinitely deep well, a point from which the fabric of space stretches downward forever. This is a black hole. It is not a hole in space. It is a place where space itself has become a hole. The gravity is so strong that nothing can escape. Not a planet, not a star, not even light itself. The fastest thing in the universe. There is a boundary around this point of infinite density, called the event horizon. The event horizon is not a physical surface. You could pass through it without even knowing. It is simply the point of no return. The moment you cross it, your journey only goes in one direction, inward. Imagine it like a river, flowing gently at first, and then picking up speed as it approaches a great waterfall. The event horizon is the point in the river where the current becomes stronger than any swimmer. Once you cross it, you can no longer swim back upstream. You can only flow with the current toward the waterfall. And what happens at the waterfall? What happens at the center of the black hole? At the point we call the singularity? We do not know. Our laws of physics, our understanding of reality, to break down. It is a place beyond our comprehension. Perhaps it is a point of infinite density. Perhaps it is a gateway to another universe. Perhaps it is a place where space and time simply cease to exist. It is a mystery, and in that mystery, there is a strange and beautiful peace, a place of ultimate surrender. Near the event horizon, time itself begins to behave strangely. For someone falling into the black hole, time would seem to pass normally. But for someone watching from a safe distance, the person falling in would appear to slow down, moving slower and slower and slower, until they seem to freeze at the edge, their image fading over an infinite amount of time. They would never appear to actually cross. Time stretches. It softens. It yields to the immense gravity of this silent, dark heart. It is easy to think of black holes as cosmic vacuum cleaners, sucking up everything in their path. But that is not quite right. Sagittarius A times is not actively pulling our galaxy into it. It is simply the anchor, the heavy weight at the center of the spinning pinwheel that keeps everything in its graceful, orbiting place. Our Sunday and our Earth are in no danger. We are 26,000 light-years away on a stable, peaceful orbit. We will never fall in. We are like a boat on a calm sea, circling a distant, deep whirlpool, far, far away. In fact, our galaxy's black hole is currently sleeping. It is not actively feeding on large amounts of gas and dust. The ring of light we see around it is the faint glow of the small amount of material that happens to wander too close. It is a quiet giant, resting at the heart of its creation. And it is a creator. This is another part of the secret. We think of black holes as agents of destruction, but they are also engines of creation. The immense energy released by matter falling into a black hole can trigger the birth of new stars. The powerful jets that can erupt from a feeding black hole can sculpt the shape of an entire galaxy, clearing out gas in some regions and compressing it in others, sparking new generations of suns. There is a balance, a cosmic dance between creation and destruction, between light and shadow. And at the center of it all is the silent, patient darkness of the black hole. It is the architect of our galaxy. It is the sculptor. It is the heart that gives our home its rhythm, its structure, and its shape. So let's float here for a moment. In the warm, golden light of the galactic center, let's watch the stars in their impossibly fast dance around the silent, dark partner at the center of it all. Feel the deep, resonant peace of this place. The heart of our galaxy is not a place of chaos, but a place of perfect gravitational order. A place where the most extreme object in the universe creates a strange and profound stability. Let your breath match the slow, graceful orbit of the outer stars, and let your mind rest in the deep, quiet mystery of the dark center. There is a paradox here, that darkness can be an anchor, that emptiness can be a center, that the absence of light can be the very thing that gives structure to the light. This is one of the great secrets of our Milky Way, that its heart is a heart of darkness, and that this darkness is not something to be feared, but something to be understood as a source of balance, of order, and of a deep, cosmic peace. Rest now. Rest in the golden light of the galactic core. Rest with the knowledge that you are held in a gentle, gravitational embrace by a silent, sleeping giant. At the heart of your home, you do not need to hold on to these words. Let them drift past you like the stars in their orbits. Let the images and ideas dissolve into a feeling of peace, of wonder, of deep, deep calm. We have journeyed to the heart of our galaxy and found a silent, dark anchor, a supermassive black hole that holds our starry home in a gentle, gravitational dance. We have learned that darkness can be a source of order, of stability, of peace, and now we drift outward again, away from the bright, crowded core, back toward the quieter, more familiar regions of the galaxy. But we are not returning to the home we thought we knew. We are returning with a new awareness, a new mystery to explore. Remember the stars at the edge of the galaxy, spinning too fast, held by a force we cannot see. This is where our journey takes us now, into the heart of that mystery, into the invisible. In the 1,970 seconds, an astronomer named Vera Rubin spent her nights looking at other galaxies, galaxies much like our own. She was a patient and meticulous observer, a cosmic cartographer charting the motions of distant suns. With her colleague, Kent Ford, she pointed her telescope at the Andromeda galaxy, our great cosmic neighbor, and began to measure the speed of its stars. Just like in our own Milky Way, She expected the stars at the edge of Andromeda to be moving slowly, like horses on the outside of a carousel. The laws of gravity were clear. The farther a star was from the bright, massive center, the weaker the gravitational pull, and the slower its orbit should be. But night after night, her data told her a different story. A story that didn't make sense. The stars at the edge of the galaxy were moving just as fast as the stars near the center. It was impossible. It was as if the outer horses on the carousel were keeping pace with the inner ones, defying the laws of physics. She checked her data. She checked her calculations. She looked at other galaxies, and everywhere she looked, she found the same impossible motion, the same flat rotation curve, the same cosmic puzzle. There were only two possibilities. Either our understanding of gravity, the bedrock of modern physics, was fundamentally wrong, or galaxies were not what they appeared to be. There had to be more mass, a lot more mass, an enormous, invisible halo of mass, extending far beyond the visible stars, holding them in its gravitational grip. This was a revolutionary idea, a courageous idea. To suggest that the universe was mostly invisible was to challenge the very foundations of astronomy. For centuries, we had studied the universe by studying light. Now, Vera Rubin was suggesting that the most important part of the universe was the part that emitted no light at all. Her work was met with skepticism at first, but the evidence was undeniable. And as more and more astronomers confirmed her findings, the truth began to sink in. Galaxies are not just islands of light in an empty sea of darkness. They are small, bright ships floating in a vast, invisible ocean. This invisible ocean is what we now call dark matter. What is dark matter? It is one of the deepest and most profound mysteries in all of science, and in that mystery, there is a deep and profound comfort. Let's start with what it is not. It is not the dark clouds of dust we see between the stars. Those clouds are dark because they block light, but they are made of the same ordinary matter as you and me. Carbon, oxygen, nitrogen. We can detect them. We can study them. Dark matter is different. It is not dark in the way that a shadow is dark. It is dark in the way that a perfect window is dark. It is transparent. It does not emit light. It does not absorb light. It does not reflect light. Light passes right through it, as if it isn't there at all. It is not made of atoms. It is not made of protons, neutrons, or electrons. It is something else entirely, a new kind of particle, a new ingredient in the cosmic recipe that we have not yet identified. Scientists have given these hypothetical particles poetic names: WIMPs, which stands for weakly interacting massive particles, axions, sterile neutrinos. These are just placeholders for a mystery we are still trying to solve. Deep underground, in laboratories shielded from the cosmic rays that constantly bombard our planet, scientists have built incredibly sensitive detectors, hoping to catch the faint, fleeting signal of a single dark matter particle passing through the Earth. So far, they have found nothing. The ghost continues to elude us, and yet we know it is there. We know it with an almost absolute certainty, not because we can see it, but because we can feel its presence. We feel it in the gentle, steady pull of its gravity. Dark matter makes up about 85% of all the matter in the universe. Think about that for a moment. Everything we can see, every star, every galaxy, every planet, every tree, every human being, all of it is only 15% of what is truly there. We are the visible foam on a vast, invisible ocean. Let this idea wash over you, not as a source of fear, but as a source of wonder. The universe is so much grander, so much more mysterious than it appears. And you are floating in the heart of that mystery right now. This dark matter is not just scattered randomly through space. It has a structure, a beautiful, intricate structure. It forms a vast, spherical cloud around our Milky Way, a dark matter halo. Imagine our galaxy, the bright, spinning disk of stars, as a small, luminous jewel. Now imagine that jewel is embedded in a huge, invisible sphere of crystal, a sphere that is 10 times wider than the jewel itself. That invisible sphere is the dark matter halo. It is the true body of our galaxy. The visible part, the part we call the Milky Way, is just the bright, glowing heart of this much larger, much more ancient structure. Computer simulations show us what this invisible architecture might look like. It is not a smooth, uniform cloud. It is a complex web of filaments, of streams, of clumps and knots. It is a cosmic spiderweb, and the galaxies are like dewdrops, collected at the intersections of the threads. This invisible web connects everything. It is the scaffolding of the universe. The dark matter formed first. In the early moments after the Big Bang, it began to clump together under its own gravity, forming these vast halos, these deep gravitational wells, and then of ordinary matter. The gas that would later form stars was pulled into these invisible wells, the way water is pulled into a depression in the ground. Dark matter is the architect. It laid the foundation. It built the cosmic cities, and then it turned on the lights by allowing stars to form within them. Without dark matter, galaxies as we know them would not exist. The gas would be too spread out, too diffuse, to ever collapse and form stars. The universe would be a thin, cold soup of hydrogen with no structure, no galaxies, no stars, no planets, and no life. So, this invisible substance, this ghost that surrounds us, is not an alien presence. It is our silent partner. It is the midwife of our existence. It is the reason we are here, and it is here, right now, all around you. As you lie here, resting, breathing, billions of dark matter particles are passing through your body every second. They pass through the floor, through the earth, through you. Without touching a single atom, they are streaming through this room, a silent, invisible river. Can you feel it? No, not with your senses, but perhaps you can feel it with your imagination. Feel the gentle, constant flow of this invisible substance, passing through you, connecting you to the vast, cosmic web that stretches across the entire universe. It is an intimate connection. The same substance that holds the galaxy together is passing through your very being. You are not just in the universe is in you. Let go of the need to see. Let go of the need to touch, and just feel the profound peace of being held by something so vast, so mysterious, and so fundamental. This is the invisible scaffold, the hidden architecture of our home, the silent, gravitational embrace that allows our river of stars to flow peacefully through the eons. Breathe in and feel the presence of this invisible ocean. Breathe out and let yourself dissolve into it, becoming one with the mystery. There is a deep comfort in knowing that we are supported by forces we cannot see. It teaches us a kind of faith, not a faith in things unseen, but a faith in the evidence of things felt. We feel the gravity of dark matter in the dance of the stars. We feel its presence in the very existence of our galaxy. And so, we can rest in that knowledge. We can trust that we are held. We can surrender to the deep, quiet peace of the invisible. Your body is heavy now. Your mind is quiet. You are drifting in a sea of gentle darkness, both visible and invisible. Let the story of Vera Rubin and her patient, courageous search for truth inspire a sense of peace in you. The universe reveals its secrets not to those who rush, but to those who wait, to those who listen, to those who are willing to see beyond the obvious. And sleep is a form of patient listening. It is a time when we let go of our own efforts and allow the deeper wisdom of our body and our mind to emerge. So, listen now to the silence between these words. Listen to the rhythm of your own breathing. That is, the rhythm of the cosmos. Slow, steady, and deeply, deeply peaceful. Rest now. You are floating in an ocean of dark matter. You are a part of the great invisible web, and you are safe. The ancient lights. Scene start. Sound of a soft, shimmering, ambient soundscape. It feels ancient and timeless, perhaps with very slow, gentle, high-pitched bell tones or chimes appearing occasionally and fading away. The slow, rhythmic breathing continues. Narrator voice is very soft, intimate, and filled with a sense of ancient wonder. And you continue to drift. There is no past, no future, only this gentle, floating present. Your body is at peace. Your mind is quiet. You are a vessel of stillness, floating on a cosmic sea. We have journeyed to the heart of our galaxy, and we have felt the embrace of the invisible, the dark matter that holds our home together. We have learned that our galaxy is far more than what we can see. It is a place of deep and profound mystery. And now, our journey takes another turn. We are going to travel not through space, but through time. We are going to listen to the stories told by the oldest things in our galaxy, the ancient lights. Every star is a clock, a time capsule. The light it shines is a message from the past, and the light it is made of is a record of its history, of the galaxy's history. Imagine now that you can see the light of a star, not just as a point of brightness, but as a beautiful, complex rainbow of colors, a spectrum, and woven into that rainbow are tiny, dark lines. These lines are chemical fingerprints. They tell us what the star is made of. When the universe was very young, and the first moments after the Big Bang, there were only the simplest elements: hydrogen, helium, a tiny trace of lithium. The universe was clean, pure, simple. The very first stars, what astronomers call population 3 stars, were born from this pristine gas. They were giants, monsters of hydrogen and helium, hundreds of times more massive than our Sunday. They burned with a brilliant, fierce, blue-white light, and they lived for only a very short time. They were the pioneers, the first lights to turn on in the cosmic darkness. We have never seen a population 3 star. They are all long gone. They lived and died before our galaxy even had a shape, but they did not disappear without a trace. In their fiery deaths, in colossal explosions called supernovae, they performed a kind of cosmic alchemy. They forged the first heavy elements: carbon, oxygen, iron, all the elements that are necessary for life. They seeded the universe with new possibilities. After these first giants were gone, the next generation of stars was born. We call them population 2 stars. They were born from the gas that had been lightly seasoned. With the ashes of that first generation, they still had very few heavy elements, but they were not as pure as the first stars. They carried the memory of what came before. These population 2 stars are the oldest surviving residents of our galaxy. They are the ancient ones. Many of them are still shining today, after more than 13 billion years. They are small, cool, red stars, burning their fuel so slowly, so patiently, that they will outlive almost everything else in the universe. And we can find them. They live in the outer reaches of our galaxy, in the vast spherical halo that surrounds the bright disk. They are the lonely hermits, the keepers of ancient history. When we find one of these stars and read its light, we are reading a page from the very first chapter of our galaxy's story. And then, there is our Sunday. Our Sun is a younger star, a population I star. It is rich in heavy elements, what astronomers call metals. It was born from gas that had been seeded by many, many generations of stars before it. Our Sun contains the recycled ashes of billions of long-dead suns. It is a child of a mature, well-developed galaxy. And so are you. Every atom of carbon in your body, every atom of oxygen you are breathing right now, every atom of iron in your blood was forged in the heart of a star that lived and died long before our Earth was born. You are made of stardust. You are made of ancient light. Let that thought sink deep into your being. You are not just living in the universe. The universe is living in you. You are a walking, breathing collection of stellar memories, a library of cosmic history. And as you rest here, you can feel that ancient connection, a connection to the first stars, to the patient, slow-burning red dwarfs, and to the great cycles of stellar birth and death that have shaped our galaxy for billions of years. Our galaxy was not born in a single, peaceful moment. It was built over billions of years through a process of chaotic, violent, and beautiful creation. Let's drift back in time now. Back 13.5 billion years. The universe is young. The first dark matter halos are beginning to form, pulling in the pristine gas of the early cosmos. The first stars ignite, brilliant and brief, and then explode, seeding the clouds with the first heavy elements. Small, irregular galaxies begin to form, not the grand spirals we see today, but messy, chaotic collections of stars and gas. And these small galaxies begin to find each other in the darkness. Pulled together by gravity, they begin to merge. Our Milky Way was a cannibal. It grew large by consuming its smaller neighbors. It was a slow, graceful, and relentless process of cosmic acquisition. Imagine two galaxies approaching each other in the darkness. They are not solid objects. They are vast, diffuse collections of stars, separated by immense distances. As they begin to merge, they pass through each other, and, like two ghosts, the individual stars almost never collide. The space between them is too vast, but their gravity takes hold. They are caught in a gravitational dance. They pull and stretch and distort each other. Long, beautiful tails of stars and gas are thrown out into space, creating shimmering, temporary bridges between them. They orbit each other, closer and closer, until they finally settle into a single, larger galaxy. This is how our Milky Way grew. It is a composite being, a blend of hundreds of smaller galaxies that have been woven together over cosmic time, and the evidence of this ancient cannibalism is still visible today. It is written in the motions of the stars. A few years ago, a spacecraft called Gaia began the most ambitious mapping project in human history. Its mission is to track the precise position and motion of over 1 billion stars in our galaxy. It is creating a three-dimensional movie of our Milky Way, revealing the hidden currents and streams that flow through our stellar river. And what Gaia has found is breathtaking. It has found the ghosts of the galaxies that our Milky Way consumed. Great, arcing streams of stars, all moving together in the same direction, on the same path. They are the breadcrumb trails, the leftover pieces of dwarf galaxies that were shredded and torn apart by our galaxy's gravity billions of years ago. One of the most significant of these ghosts is a galaxy that astronomers have named Gaia Enceladus. About 10 billion years ago, this galaxy, which was about 1/4 of the size of the young Milky Way, collided with our own. The merger was a cataclysmic event that puffed up our galaxy's halo and triggered a great burst of star formation. Many of the ancient stars in our galaxy's halo were not born in the Milky Way. They are immigrants. They are the surviving residents of Gaia Enceladus and other small galaxies like it. They are celestial refugees, carrying the memory of a home that no longer exists. And this process is still happening. Right now, the Sagittarius dwarf galaxy is passing through the disk of our Milky Way. It is being torn apart, its stars stripped away, forming a great looping river of light that wraps around our entire galaxy. In a few more passes, it will be completely dissolved, its stars blended into the great stream of the Milky Way, its separate identity lost forever. So, when you look up at the night sky, you are not just seeing the Milky Way. You are seeing a collage, a mosaic, a beautiful, complex tapestry, woven from the threads of countless smaller galaxies, over 13 billion years of cosmic history. And the atoms in your body may not all come from the same place. Some may have been forged in stars that were born in the original proto-Milky Way. Others may have come from stars in Gaia Enceladus. Still others from even smaller galaxies that were consumed long, long ago. You are a child of many parents, a descendant of 1,000 forgotten galaxies. Your very substance is a testament to this long, slow, beautiful history of cosmic merging and creation. Let this story of creation and transformation be a source of deep peace for you. It is a story of how things come together, how they blend, how they form something new and beautiful out of the old. It is the story of the universe itself, a story of constant, patient recycling. Every time a star dies, it releases its elements back into the galaxy. These elements mix with the great clouds of gas and dust that drift between the stars. And from these enriched clouds, new stars are born, and new planets, and perhaps new life. Each generation builds upon the last. The first stars created carbon. The next generation used that carbon to create more complex elements, and so on, and so on. Over billions of years, the galaxy has become richer, more complex, more filled with the ingredients necessary for life. It is a slow, patient process. The universe is in no hurry. It has all the time in the world, and you are the result of that patience. You are the result of 13 billion years of cosmic chemistry. The iron in your blood that carries the oxygen you are breathing was created in the heart of an exploding star billions of years ago. The calcium in your bones was forged in another long-dead sun. The carbon that forms the backbone of your DNA is a gift from the stars, the question and the future. A being of stardust, floating in a river of light, held by an invisible hand, in a galaxy woven from the ghosts of ancient suns. Our galaxy, our home, contains 400 billion stars, 400 billion suns, and in the last few decades, we have learned that most of them have planets. Our galaxy is filled with worlds, trillions of them. Many of these worlds orbit their stars in what we call the habitable zone, the Goldilocks region. Not too hot, not too cold, but just right for liquid water to exist on their surface. Liquid water, the one ingredient that seems to be essential for life as we know it. 400 billion stars, trillions of planets, billions of worlds in the right place for water. The numbers are staggering. They whisper a tantalizing possibility that life is not a rare miracle, but a common, natural outcome of cosmic chemistry, that the universe is teeming with it. And so, we ask the question that has haunted our quiet moments and our late-night conversations for generations. the question posed by the physicist Enrico Fermi on a lunch break in 1950. If life is common, then where is everyone? This is the Fermi Paradox, the great silence. Our galaxy has been here for over 13 billion years. Civilizations could have risen and fallen 1 billion times over. They could have spread across the galaxy, leaving their mark, their signals, their presence. And yet, when we listen, with our great radio telescopes, we hear nothing, only the faint cosmic hiss of the universe itself, a profound and unsettling silence. Where is everyone? Perhaps life is much harder to start than we think. Perhaps the leap from non-living chemistry to a living cell is a once-in-a-universe miracle. Perhaps intelligent life is rare. Perhaps there are countless worlds of microbes and plants. But the evolution of a mind that can ask questions about the universe is an incredible fluke. Or perhaps civilizations, once they reach a certain level of technology, inevitably destroy themselves. A sobering and humbling thought. Perhaps the universe is a dangerous place, and the wise civilizations are the ones that stay quiet, the ones that don't broadcast their existence to the cosmos, for fear of attracting unwanted attention. Or perhaps they are here, all around us, but we lack the senses to perceive them. Perhaps they communicate in ways we cannot comprehend, or exist in dimensions we cannot access. Perhaps we are like an ant colony in the middle of a bustling city, unaware of the complex civilization that surrounds us. And perhaps the most beautiful and poignant possibility of all is that we are simply the first, or one of the first, that in our corner of the galaxy, on this small, blue world, consciousness has awakened. And it is our destiny, our privilege, to be the ones who carry that spark of awareness out into the great, silent darkness. We do not know the answer, and in that not knowing, there is a profound peace. It is the peace of letting go, the peace of accepting the mystery. We can rest in the question. We can find comfort in the wonder. And the search continues. With our new, powerful telescopes, like the James Webb Space Telescope, we are beginning to look at the atmospheres of distant worlds. We are searching for biosignatures, the chemical fingerprints of life, the telltale signs of oxygen, of methane, of a planet that is breathing. We may find the answer in your lifetime, or in 1,000 years, or we may never find it. But the search itself is a noble one. It is an expression of our deepest curiosity, our deepest longing to know if we are alone. And as you drift now, in the quiet of your own mind, you can hold that question, not as a problem to be solved, but as a gentle wonder, a koan, a sacred mystery. Are we alone? Let the question dissolve into the vast, silent peace of the cosmos. And as we contemplate the great question of life, the galaxy itself continues its slow, patient journey through time, and its future is already written in the stars. As we look out into the night sky, there is another galaxy that looms large in our cosmic neighborhood, the Andromeda galaxy. It is a sister galaxy to our own, slightly larger and even more beautiful, and it is moving toward us at a speed of 110 kilometers per second. In about 4.5 billion years, our two galaxies will meet, they will collide, and they will merge. Let this thought not be a source of alarm, but of awe. This will not be a violent, destructive event. It will be a slow, graceful, cosmic dance that will unfold over hundreds of millions of years. Remember, galaxies are mostly empty space. When the Milky Way and Andromeda merge, the individual stars will not collide. Our Sunday and our Earth will be perfectly safe. We will simply be swept up in a great gravitational tide. The night sky, during this time, will be a spectacle of unimaginable beauty. Andromeda will grow larger and larger until it fills the entire sky. A great, swirling river of new stars arching from horizon to horizon. We will see its spiral arms, its bright core, its nebulae, as if we could reach out and touch them. And as the two galaxies merge, their structures will be torn apart and reformed. The beautiful spirals will be disrupted. Great streams and tails of stars will be flung out into space. And, eventually, over hundreds of millions of years, they will settle into a new, stable shape. A single, giant, elliptical galaxy. A new creation, born from the union of two old ones. Astronomers have already given it a name, Milkomeda, or Milkdromeda, our Sunday, but will likely be pushed out into the far outer regions of this new giant galaxy. Our home will have a new address in a new kind of cosmic city, and the night sky will be forever changed. This is the future of our galaxy, a future of transformation, of merging, of becoming something new. And even that is not the end of the story. The universe is a story of deep, deep time, and on the longest of timescales, even the stars themselves will fade. Trillions of years from now, the great clouds of gas and dust will be used up. Star formation will cease. The galaxy will stop making new suns. The bright blue stars will have long since burned out. The yellow stars, like our Sunday, will have faded to white dwarfs and then to cold black cinders. For a time, the galaxy will be lit only by the faint red glow of the longest-lived stars, the red dwarfs. They will burn for trillions of years, like cosmic embers in the growing darkness. But eventually, even they will go out, and the galaxy will become a silent, dark graveyard of stellar remnants, a collection of black holes, neutron stars, and cold, dead planets, orbiting a central, supermassive darkness. And even then, the story is not over. Over unimaginable timescales, even this dark galaxy will dissolve. The black holes will evaporate through a process called Hawking radiation, returning their energy to the universe in a final, faint whisper. The dead stars and planets will be stripped from their orbits and wander alone into the expanding, empty darkness, until finally, there is nothing left, only a cold, dark, and empty universe in a state of perfect, final peace. The heat death of the universe. Let this vision of the far, far future not be a source of sadness, but of profound peace. It is a reminder that everything is temporary. Everything that begins must end. And in that ending, there is a kind of perfection, a final, complete, and total rest. It is the ultimate letting go. And it is so far in the future that it is beyond all comprehension. It is a story, not for us, but for the universe itself. And so, we have journeyed from the beginning to the end. We have seen the birth of our galaxy, its life, and its ultimate, peaceful dissolution. And in all of this, what is the biggest secret? We have encountered so many. The secret of the invisible dark matter that holds us together. The secret of the dark heart, the black hole that anchors our galaxy. The secret of our own stardust origins, the ancient light in our veins. But perhaps the biggest secret of all is not a thing. It is not a fact. It is a realization. The secret is this: we are not just living in the galaxy. We are the galaxy. We are the universe, becoming aware of itself. Think of it. For 13 billion years, Our galaxy has been spinning in the darkness, a beautiful, complex, and unthinking machine. It has been following the laws of physics, creating stars, merging with its neighbors, all without any awareness and any consciousness, any mind to appreciate its own beauty. And then, on one small planet, orbiting one ordinary star, in a quiet, spiral arm, the stardust woke up. The recycled atoms of ancient, exploded suns came together in a new and complex way, and they began to think. They began to wonder. They began to look up at the river of light in the sky and ask, "What is that?" That is us, you, me. We are the part of the galaxy that can think. We are the part that can feel wonder. We are the part that can appreciate the beauty of a sunset, the mystery of a distant star, the profound peace of a quiet moment. The stellar nurseries, we have journeyed through the vastness of our galaxy. We have felt its invisible embrace, and we have touched the ancient light of its oldest stars. We have learned that we are a part of a story of immense scale and profound connection. And now, our journey takes us to a place of creation, a place of birth. We are going to drift into the soft, warm, glowing clouds where new stars are born. We are going to visit the stellar nurseries of our Milky Way. Imagine now that you are drifting away from the well-trodden paths of the spiral arms and moving toward a vast, dark cloud. From the outside, it looks like a hole in the fabric of the cosmos, a place where the stars have been erased, a patch of profound, empty blackness. But this darkness is not emptiness, it is fullness. It is a giant molecular cloud, a vast, cold, dense collection of hydrogen gas and cosmic dust. It is so dense that the light from the stars behind it cannot pass through. It is a veil, hiding a secret world of creation. Let us drift closer now and pass through that veil. As we enter the cloud, the world outside disappears. We are enveloped in a soft, cool, and gentle darkness. It is not a frightening darkness, but a peaceful, quiet, waiting darkness. It is the darkness of a seed buried deep in the earth. It is the darkness of a womb before life begins to stir. Here, in the heart of this molecular cloud, the temperature is just a few degrees above absolute zero. The atoms are moving slowly, peacefully, but gravity is always at work, patiently, relentlessly. Within this vast cloud, there are regions that are slightly denser than others. Small, cosmic knots in the fabric of the gas, and gravity begins to pull on these knots. It is a gentle pull, almost imperceptible at first, but over millions of years, that gentle pull becomes stronger. Imagine one of these knots now, a small, dark core within the larger cloud. It begins to draw gas and dust toward itself. It is a process of gathering, of collecting, of building. The core grows denser and denser, and as it does, the pressure at its center begins to rise. The core begins to warm up, a faint, gentle heat in the midst of the cosmic cold. It is not yet a star. It is a protostar, a star in embryo, a promise of light, wrapped in a blanket of gas and dust. Let us drift toward one of these protostars now. We see it as a warm, glowing heart, buried deep within the dark cloud. Around it, a flat, spinning disk of dust and gas has formed, a protoplanetary disk. This is where future worlds will be born, the leftover material from the creation of the star. It is a place of incredible beauty and peace, a cosmic nursery where a new sun is being carefully and patiently assembled. Feel the warmth of this young star. Feel the gentle, creative energy of this place. It is a place of pure potential, a place of beginnings, Our own Sunday was born in a place just like this 4.5 billion years ago. It was once a protostar, a warm, glowing core in a dark cloud. And our Earth was once just a collection of dust and pebbles in the protoplanetary disk that surrounded it. This process of creation is happening right now, all across our galaxy, in the great, beautiful clouds of the Orion Nebula, a stellar nursery we can see with a small telescope. Thousands of new stars are being born. It is a vast, cosmic city of light and creation, a place of breathtaking beauty. Imagine floating there now. You are surrounded by the brilliant light of young, hot blue stars. Their powerful stellar winds are carving great caves and pillars into the surrounding gas. The gas itself is glowing with vibrant colors, pinks and reds from excited hydrogen, blues and greens from oxygen. It is a celestial watercolor painting, created by the hands of gravity and light. We see the famous pillars of creation in the Eagle Nebula, great, towering columns of gas and dust, taller than our entire solar system. And at the tips of these pillars, we can see the small, dense knots where new stars are being born, their gentle, infrared light just beginning to shine through. It is a place of profound and dynamic beauty, a place where destruction and creation happen side by side. The very stars that are being born are also destroying the cloud that gave them life. They are blowing it away, clearing out their nursery, so that their light can shine out into the galaxy. Let the beauty of this place fill your awareness. Let it be a source of deep peace and wonder. The universe is not a static, unchanging place. It is alive. It is dynamic. It is constantly creating itself anew. And you are a part of that creation. The atoms in your body were once part of a great molecular cloud just like this one. They were drawn together by gravity to form a star. They were forged into heavier elements in that star's fiery heart. They were released back into the galaxy in a great supernova explosion, and then they were gathered up again in a new cloud to form a new star and a new family of planets. The life cycles of stars. Imagine a star much like our own Sunday. It has just been born. It has ignited, and its light shines out into the galaxy. It has entered the longest and most stable phase of its life, the main sequence. For billions of years, it will be a beacon of stability, a reliable source of light and warmth. At its core, it is performing a constant, gentle miracle. It is taking hydrogen, the simplest element, and through the immense pressure and heat of its heart, it is fusing it into helium. This process, nuclear fusion, is the engine of the star. It is what makes it shine. Our sun is in this phase now. It has been shining peacefully for 4.5 billion years, and it will continue to do so for another 5 billion years. It is a symbol of constancy, of patience, of the long, quiet, middle passage of a life well lived. Let the stability of our Sunday be a source of deep comfort for you. It is a steady presence, an anchor in our cosmic neighborhood. Its light is the light of a star in its peaceful prime, but nothing, not even a star, can last forever. After billions of years of patiently turning hydrogen into helium, the star will begin to run out of fuel in its core. The engine will begin to falter, and the star will begin to change. As the core runs out of hydrogen, the delicate balance between gravity pulling inward and the outward pressure of fusion is disrupted. Gravity begins to win. The core contracts and grows even hotter. This new, intense heat causes the outer layers of the star to expand dramatically. The star swells like a great cosmic balloon. It becomes a red giant. Its surface cools, giving it a reddish-orange glow. It becomes hundreds of times larger than it was before. When our sun becomes a red giant, it will swell to engulf the orbits of Mercury and Venus, and perhaps even our Earth. Let this image not be one of destruction, but of transformation. It is a natural and necessary part of the star's journey. It is a star in its old age, grand, majestic, and beautiful. Inside the red giant, the star begins a new chapter of creation. The core is now hot enough to fuse helium into carbon and oxygen. The star has learned a new trick. It is continuing its work of cosmic alchemy, creating the very elements that are essential for life. But this phase is much shorter. After a few 100 million years, the helium fuel also begins to run out. And for a star the size of our Sunday, the journey is nearing its end. There is not enough mass, not enough gravity to ignite the carbon and oxygen. The fusion engine shuts down for good. The star can no longer hold itself up against the pull of its own gravity. What happens next is a quiet and graceful letting go. The star sheds its outer layers. Great, beautiful clouds of gas are puffed out into space. Like a final, gentle sigh, these clouds form a beautiful, glowing shroud around the dying star. We call them planetary nebulae. They are some of the most beautiful objects in the cosmos. Great, intricate, glowing bubbles of gas, like cosmic smoke rings or the petals of a celestial flower. They are the star's final gift to the galaxy, a gift of newly forged elements that will one day be recycled into new stars and new worlds. And at the center of this beautiful, expanding cloud is all that remains of the star's core, a tiny, incredibly dense, and intensely hot object called a white dwarf. It is the stellar remnant, the memory of the star that was. A white dwarf is about the size of the Earth, but it contains the mass of a sun. A single teaspoon of its material would weigh several tons. It no longer generates new heat. It is simply a cooling ember. For trillions of years, it will slowly fade like a dying campfire until it becomes a cold, dark, black dwarf, a stellar ghost, drifting silently through the darkness. This is the peaceful end for most of the stars in our galaxy. A quiet, fading, a gentle release. A return to the darkness from which they came. But what about the giants? The massive stars, 10, 20, 50 times the mass of our sun? Their lives are very different, and so are their deaths. These massive stars live fast and die young. They burn through their fuel with a ferocious intensity. They are the brilliant, blue-white beacons of the galaxy, but their lives last for only a few million years, a mere blink of an eye in cosmic time. And when they die, they do not go quietly. They go out in a blaze of glory. Like a smaller star, they fuse hydrogen into helium and helium into carbon. But they are so massive, their cores are so hot that they can continue the process. They fuse carbon into neon, neon into oxygen, oxygen into silicon, and finally, silicon into iron. And with iron, the journey ends. Iron is the most stable element. Fusing iron does not release energy, it consumes it. The star's engine has reached a dead end. The core is now a dense ball of iron, and it can no longer hold back the immense weight of the star's outer layers. In a fraction of a second, the balance is broken. Gravity wins catastrophically. The core collapses with unimaginable speed. The outer layers of the star come crashing down onto the collapsed core and then rebound in the most powerful explosion in the universe, a supernova. For a few weeks, the single, dying star can outshine an entire galaxy of billions of stars. It blazes with the light of 1,000,000,000,000 suns. It is a final, triumphant shout, a glorious and spectacular farewell. And in that explosion, the star gives its greatest gift. The shockwave is so powerful that it forges all the elements heavier than iron, gold, silver, platinum, uranium. Every atom of these precious elements in the universe was created in the fiery death of a massive star. This explosion is not an act of destruction. It is an act of cosmic generosity. It is the star scattering its hard-won treasures across the galaxy, seeding the clouds of gas and dust with all the ingredients necessary for complex planets and for life. And what is left behind? After the light of the supernova fades, we find one of two things. For most massive stars, the collapsed core remains as a neutron star, an object so dense that all its protons and electrons have been crushed together to form neutrons. It is a city-sized object with the mass of a sun. A single grain of its material would weigh more than Mount Everest. And for the most massive stars of all, the collapse of the core does not stop. Gravity is so strong that it crushes the core down to an infinitely small point. It creates a stellar mass black hole, a new heart of darkness, born from the death of a brilliant light. This is the cycle, the cosmic dance of life and death. Small stars fade peacefully, leaving behind a gentle memory. Large stars die in a blaze of glory, scattering the seeds of new creation. And from this constant, patient rhythm of transformation, the galaxy is constantly renewed. Let this cycle be a source of deep peace for you. It is a reminder that every ending is a new beginning, that death is not a finality, but a transformation, that nothing is ever truly lost, but only changed. Your body is a part of this cycle. The atoms within you have participated in this dance for billions of years. They have been through the hearts of stars and the fire of supernovae. They have been part of nebulae and white dwarfs, and perhaps even neutron stars. The spaces between, we have journeyed to the places of light, the stellar nurseries where stars are born, and the brilliant supernovae where they die. We have focused on the objects, the stars, the planets, the nebulae. But now, we are going to turn our attention to something different. We are going to explore the spaces between, the vast, quiet, and seemingly empty voids that separate the stars, the interstellar medium. When we look up at the night sky, it seems to be made of two things: bright points of light and the black, empty space that surrounds them. And it is easy to think of that space as nothing, a vacuum, an absence. But this is another one of the great, quiet secrets of our galaxy. The space between the stars is not empty. It is filled with a thin, diffuse, and incredibly important substance, a tenuous mixture of gas, dust, and cosmic rays that permeates the entire galaxy. Imagine that you could shrink down to the size of a single atom, and you could float in the space between the stars. You would find that you are not alone. Every few cubic centimeters, you would encounter an atom of hydrogen. Every now and then, an atom of helium, and occasionally, a tiny, microscopic grain of dust, made of carbon, or silicon, or iron. This is the interstellar medium. It is 1,000,000,000,000 times less dense than the air you are breathing. But the galaxy is so vast that this thin, cosmic soup adds up to an enormous amount of material. In fact, about 15% of all the visible matter in our galaxy's disk is found in this space between the stars. It is the galaxy's atmosphere, its circulatory system, It is the raw material from which new stars are made, and it is the repository for the elements created by dying stars. Let us drift through this space now. It is a place of profound quiet and stillness. The distances between atoms are vast. The silence is absolute. It is a place of deep and meditative peace. There is a beauty in this emptiness, a comfort in this vast, open space. It is the space that allows the stars to be themselves. It is the silence that allows the music of the cosmos to be heard. In our own lives, we often focus on the objects, the events, the things we need to do. But perhaps the most important part of life is the space between, the quiet moments, the pauses, the times when we are simply being. Let yourself feel that now. The peace of the space between, the comfort of the quiet, the freedom of the void. This interstellar medium is not uniform. It is a complex and beautiful landscape of its own. There are vast, cold, dark clouds, like the stellar nurseries we have already visited, and there are hot, glowing bubbles of gas that have been heated and pushed aside by the winds of young, massive stars, or by the shock waves of ancient supernovae. There are regions where the gas is neutral, and regions where it has been ionized, its electrons stripped away by the intense radiation of nearby stars. It is a dynamic and ever-changing environment. And drifting through it all are the tiny grains of cosmic dust. These are not like the dust bunnies under your bed. They are microscopic particles, smaller than the wavelength of light. They are made of the heavy elements forged in stars: carbon, silicon, magnesium, iron, all coated in a mantle of water ice, ammonia, and methane. This dust is incredibly important. It is the key ingredient for making planets, and it is the key ingredient for making life. These tiny, frozen grains of dust are the seeds of worlds. They are the building blocks of everything we know, and they are what make the sky look so beautiful. When the light from a distant star passes through a cloud of this dust, the blue light is scattered away, while the red light passes through. This is why sunsets on Earth are red, and it is why distant stars, seen through a dusty cloud, appear redder than they really are. The dust is a cosmic artist, painting the galaxy with subtle shades of color and light. It also creates a beautiful phenomenon called reflection nebulae. If a cloud of dust is near a bright blue star, it will scatter the blue light, and the cloud itself will appear to glow with a soft, ethereal blue light. It is like a cosmic fog illuminated by a single, distant streetlight. So this emptiness is not empty at all. It is filled with potential. It is filled with beauty. It is filled with the very stuff of life. Let us find a place of deep quiet now, in the heart of one of these vast interstellar voids, a place far from any star, far from any cloud, a place of profound and perfect blackness, the magnetic fields. And now, we are going to become aware of another invisible force, another secret hidden in plain sight. We are going to feel the magnetic field of the Milky Way. Like our Earth, our galaxy has a magnetic field. It is a vast, complex, and incredibly faint web of magnetic energy that permeates the entire disk and halo. It is 1,000,000 times weaker than the magnetic field of the Earth. You could not feel it with a compass, but on a galactic scale, its influence is immense. Imagine now that you can see these magnetic field lines. They are like glowing, ethereal threads, weaving their way through the space between the stars. They follow the curve of the spiral arms. They loop and swirl around the galactic center. They form a great, invisible, magnetic skeleton that helps to give the galaxy its shape. These fields are generated by the motion of charged particles, the plasma that makes up much of the interstellar medium, the spinning of the galaxy. twists and stretches these fields, creating the complex, beautiful structure that we are only now beginning to map. Let us drift with these lines of force now. Feel yourself being gently guided by this invisible current. There is no resistance, no effort. You are simply flowing with the magnetic river of the galaxy. This magnetic field has a profound effect on everything within it. It acts as a kind of cosmic highway for high-energy particles called cosmic rays. These are protons and atomic nuclei that have been accelerated to nearly the speed of light by supernovae and other violent events. They are the wild children of the galaxy, zipping through space with incredible energy. But they are not free to go wherever they please. They are caught by the galaxy's magnetic field. They spiral around the field lines like beads on a string. They are guided on long, curving journeys through the interstellar medium. The magnetic field tames them. It contains them. It keeps them from escaping into intergalactic space. And this magnetic field also plays a crucial role in the birth of stars. When a great molecular cloud begins to collapse under its own gravity, the magnetic field that threads through it can act as a brake. It can slow the collapse, giving the cloud more time to fragment into smaller pieces, allowing for the formation of many smaller stars instead of just one giant one. It is a force of moderation, a gentle hand that guides the process of creation. It also helps to channel the gas and dust into the spinning disk that forms around a young protostar. It is a cosmic shepherd, herding the raw materials of creation into the places where they are needed most. So this invisible force, this faint magnetic whisper, is a sculptor of worlds, a shaper of stars, a guide for the lost particles of the cosmos. And it is flowing through you right now. As you lie here, you are part of this vast galactic magnetic web. You are aligned with the great slow turning of the Milky Way. There is a deep peace in surrendering to these unseen currents in our lives. We often try to force our way, to push against the current, to control the outcome, but the galaxy teaches us a different way, the way of yielding, the way of flowing, the way of trusting the invisible forces that guide us. Can you feel that now? The feeling of letting go, of allowing yourself to be carried, of trusting the great, slow, wise currents of the universe are carrying you exactly where you need to be. Let your breath be your guide. With every breath in, feel the gentle, guiding energy of the cosmos flowing into you. And with every breath out, release your own efforts and surrender to the flow. There is no need to know the destination. The journey is everything. And the journey is a slow, peaceful, and beautiful drift on the magnetic rivers of space. Let your mind become as fluid and as yielding as these lines of force. Let it bend and curve and flow with the gentle, guiding wisdom of the universe. There is no resistance here. There is no struggle. There is only the peace of surrender, the comfort of being held and guided by a force that is infinitely larger and wiser than yourself. Sleep now. The magnetic field of the galaxy is your cradle. It is rocking you gently. In its vast, invisible arms, you are safe, you are guided, and you are flowing toward a place of deep and profound rest. The galactic rotation. Our journey has shown us the hidden structures of our home, the dark heart, the invisible scaffold, the magnetic web, and now we are going to become aware of the motion that ties it all together, the motion that generates the magnetic fields, the motion that defines our place in the cosmos. We are going to feel the galactic rotation, our galaxy is spinning. It is a great cosmic carousel, a celestial pinwheel, turning slowly in the darkness. But it does not spin like a solid object. It spins with a beautiful and complex differential rotation. Imagine a whirlpool in a quiet pond. The water at the center spins quickly. The water at the edge moves more slowly. This is how our galaxy spins. The inner regions complete their orbit in a shorter time than the outer regions. Our Sunday and our solar system are part of this great, slow dance. We are located about halfway out from the center, and we are moving at a speed of about 220 kilometers per second. It is a speed that is almost impossible to comprehend, and yet the circle is so vast that it takes us over 200 million years to complete a single orbit, a single galactic year. Let us feel this motion now, not as a dizzying speed, but as a slow, graceful, and majestic waltz. Imagine yourself and our entire solar system drifting in a great, sweeping arc around the glowing heart of the Milky Way. There is no sense of speed. There is only a sense of gentle, constant, and inevitable movement. It is a motion that is so large and so slow that it becomes a kind of stillness, a dynamic peace, a moving rest. This is the rhythm of our home, the great, slow turning of the cosmic wheel. It is a rhythm that has been beating for billions of years. It is the heartbeat of our galaxy, and you are a part of that rhythm. Your own heartbeat, your own breath are tiny, fleeting echoes of this great cosmic pulse. As you breathe in and out, you are participating in the life of the galaxy. You are moving with the slow, patient, and eternal turning of the universe. There is a deep comfort in being a part of a motion so grand, it takes the pressure off. It reminds us that we are not in control. We are simply along for the ride, and the ride is beautiful. Let go of any need to direct your life. Let go of any need to know the destination, and just feel the gentle, forward momentum of this great cosmic dance. You are being carried, you are being moved, and you are safe. This galactic rotation is what gives our galaxy its beautiful spiral shape. The spiral arms are not solid structures, they are patterns. They are density waves moving through the disk of the galaxy, like ripples on a pond. As the wave passes through a region of gas and dust, it compresses it, triggering the birth of new stars. This is why the spiral arms are so bright. They are the crests of the cosmic waves, illuminated by the light of their newborn suns. The stars themselves are not permanently in a spiral arm. They drift in and out of these density waves. Our own Sunday has passed through many spiral arms in its long life, and it will pass through many more. So, the beautiful spiral pattern that we see is not a static thing. It is a dynamic and ever-changing dance of stars and gas and gravity. It is a cosmic choreography on a scale of unimaginable grandeur. The satellite galaxies. Our journey has taken us deep into the heart of our own galactic home. We have explored its secrets, its structures, and its motions. We have come to know the Milky Way as a place of profound beauty and connection. But our galaxy is not alone. It does not travel through the great dark void of intergalactic space in solitude. It is the heart of a family, a small and intimate community of galaxies, all bound together by the gentle, invisible thread of gravity. Let us drift outward now, beyond the shimmering disk of our own Milky Way, beyond the vast, invisible halo of dark matter that surrounds it. We are moving into the space around our galaxy, and as we look back, we see our home as a beautiful, spinning island of light in a vast, dark ocean. But it is not the only island. As our eyes adjust to the deep darkness, we begin to see other, smaller islands of light, faint, ghostly smudges against the black velvet of space. These are the satellite galaxies of the Milky Way, our cosmic companions, our little brothers and sisters in the galactic family. There are dozens of them, small, dwarf galaxies, each containing a few million or a few billion 10 stars. They are all caught in our galaxy's gravitational embrace, orbiting our much larger Milky Way. Just as the planets orbit the Sunday, they are our moons on a galactic scale. From the southern hemisphere of our Earth, 2 of these companions are visible to the naked eye. They look like 2 faint, detached pieces of the Milky Way, 2 small, luminous clouds. For millennia, they were known only to the people of the southern lands. But in the 16th century, the explorer Ferdinand Magellan made his famous journey around the world, and his crew recorded the presence of these 2 mysterious clouds, and so they became known as the Large and Small Magellanic Clouds. Let us drift toward them now. They are our closest and brightest neighbors. As we approach the Large Magellanic Cloud, we see that it is a beautiful, if somewhat messy, spiral galaxy. It is a place of vibrant creation. It is filled with bright, blue, young stars, and great, glowing nebulae of pink and red. It is a chaotic and energetic young galaxy, buzzing with the activity of star birth. It is a beautiful contrast to the more settled and stately grace of our own Milky Way. It is the wild and creative younger sibling. And nearby is the small Magellanic Cloud, even smaller and more irregular. It is being stretched and distorted by the gravitational pull of both the Milky Way and its larger companion. It is a galaxy in transition, its stars being pulled away to form a great gaseous bridge that connects the 3 galaxies. This is a family that interacts, that shares, that influences one another. We are not separate. We are connected by these invisible bridges of gravity and these visible streams of stars and gas. And beyond the Magellanic Clouds, there are others, so many others. The Sagittarius dwarf, which we have already seen being slowly consumed by our galaxy. The Canis major dwarf, the closest of all, so close that it is being shredded into a great ring of stars that encircles our galaxy. The Ursa minor dwarf, the Draco dwarf, the Sculptor dwarf. Their names are like the names of old, forgotten friends. Each one is a tiny, ancient galaxy with its own history and its own story. Many of them are made of old, red stars, their star-forming days long since past. They are the quiet, wise elders of our galactic family, orbiting peacefully in the great, dark halo. Let the presence of these companions be a source of deep comfort for you. It is a reminder that we are not alone. Our galaxy is not a solitary wanderer in the void. It is the heart of a community, a family, a clan, the galactic plane. Let us drift back now from the deep, dark space between the galaxies and re-enter our own home. We pass through the vast, spherical halo of ancient stars and dark matter, and we descend into the galactic plane. This is the part of the galaxy we call home, the bright, flat, spinning disk where most of the stars and gas and dust reside. It is a place of incredible thinness. While our galaxy is 100,000 light-years across, the disk is only about 1,000 light-years thick. On a cosmic scale, it is thinner than a piece of paper, a vast, luminous, and incredibly delicate structure. And we live inside it. Our solar system is embedded in the middle of this plane, and because we are inside it, our view of the universe is unique and limited. Imagine you are a tiny microbe, living inside a single sheet of paper. Your entire world is two-dimensional. You can see along the paper, but you cannot see what is above it or below it. This is our perspective on the galaxy. When we look up at the night sky, and we see that beautiful, hazy band of light, the Milky Way, we are looking along the plane of the paper. We are looking into the dense, crowded, and distant parts of our own galactic disk. The light from billions of distant stars all blends together to form that beautiful Milky River. And when we look away from that band, in any other direction, we are looking out of the paper. We are looking up or down into the much emptier space of the galactic halo. The stars are fewer and farther between. The sky is darker and more open. This is why the Milky Way appears as a band across our sky. It is an accident of our perspective, a consequence of our position, living inside a flat, disc-shaped galaxy. There is a profound and peaceful lesson in this. The lesson of accepting our own limited perspective. We can never see our galaxy as it truly is. We can never step outside of it to see the beautiful, complete spiral pattern. We can only see it from our own particular and partial point of view, and that is okay. In fact, it is more than okay. It is beautiful. In our lives, we often wish for a different perspective. We wish we could see the whole picture. We wish we could understand everything from every angle. We struggle with the limitations of our own viewpoint, but the galaxy teaches us the peace of partial understanding, the comfort of accepting that we can only see what we can see from where we are, and that what we can see is beautiful enough. Let yourself feel that peace now, the peace of letting go of the need to know everything, the peace of accepting your own unique and beautiful perspective. You are not required to see the whole universe. You are only invited to appreciate the view from your own window. And the view is spectacular. From our place within the galactic plane, we are surrounded by the raw materials of creation, the great clouds of gas and dust, the bright, young stars, the open clusters, all drift by in the slow, majestic rotation of the disk. But this plane is also a place of obstruction. The very dust that creates new worlds also blocks our view. There are vast regions of our own galaxy that we cannot see in visible light. The galactic center itself is hidden behind a thick veil of interstellar dust. It is a secret kept from our eyes by the very substance that gives us life. And so, we must be clever. We must learn to see with different kinds of eyes, with radio eyes that can see the cool hydrogen gas, with infrared eyes that can see through the dust, with X-ray eyes that can see the hot, violent events near the core. Our understanding of our galaxy is a mosaic, a patchwork of different views, different kinds of light, all pieced together to create a more complete but still partial picture. And this too is a beautiful metaphor for life. We can never understand another person completely. We can never know the full story. We can only gather clues, listen to what is said and what is not said, and piece together our own partial and compassionate understanding. The halo stars. This is the halo, a vast spherical region that surrounds the entire visible galaxy. It is the galaxy's attic, its memory chest. It is the home of the oldest and wisest residents of our Milky Way. Here, there are no stellar nurseries, no bright, young blue stars, no great clouds of gas and dust. The star-forming days of the halo are long since past. The stars that live here are ancient. They are the survivors, the first generation, the keepers of the galaxy's oldest secrets. They are the population 2 stars that we met on our journey through time. They are made of almost pure hydrogen and helium, with only a tiny trace of the heavier elements. They are the living fossils of a younger, simpler universe. These halo stars do not travel in the same orderly, circular orbits as the stars in the disk. They move in long, looping, elliptical paths. They plunge down through the disk and then soar high above it, like cosmic dolphins leaping from the water. They are the wild ones, the wanderers, the free spirits of the galaxy. Let us drift alongside one of these ancient wanderers now. It is a small, cool, red star. It burns its fuel with an incredible patience. It has been shining for 13 billion years. It was born, Hope DG's out, when the universe was just a baby. It has witnessed the entire history of our galaxy, the first mergers, the formation of the disk, the birth of our own Sunday. It has seen it all. What wisdom does this ancient star hold? What stories could it tell? It cannot speak in words, but it speaks in a language of light, a language of constancy, a language of patience. It teaches us the wisdom of deep time, the wisdom of knowing that all things are temporary, all struggles, all triumphs, all moments of joy and sorrow are fleeting ripples on the surface of a vast and ancient ocean. This star has outlasted them all, and it will continue to shine long after we are gone. There is a profound peace in this perspective, a letting go of the urgency and the drama of our own short lives, a surrender to a timescale that is beyond our comprehension, a timescale upon which all our worries simply dissolve. And scattered throughout this vast halo are other ancient treasures, great spherical collections of stars called globular clusters. Imagine one now, a beautiful, glittering, cosmic snowball, hundreds of thousands of ancient stars, all packed together in a tight, spherical swarm. They are all the same age. They were all born together from the same cloud of gas in the very early days of the galaxy. They are a star cluster, a family that has stayed together for 13 billion years. Drifting into a globular cluster is like stepping into a celestial jewel box. You are surrounded on all sides by the soft, golden light of ancient yellow and red stars. The density is incredible. At the center, the stars are so close together that the night sky would be a continuous, blazing canopy of light. These globular clusters are the oldest intact structures in our galaxy. They are the galactic elders, the wise councils. They have seen everything, and they hold themselves in a state of perfect gravitational balance, a state of ancient and profound peace. Let the light of these ancient stars and these ancient clusters wash over you. It is a light that is filled with wisdom, with patience, with the quiet strength of survival. It is a light that has seen the universe change and has remained constant. The center's mysteries. Our journey has taken us far and wide. We have explored the visible and the invisible, the new and the ancient. And now we are drawn back to the place of greatest mystery, back to the heart of our galaxy. We have already visited the galactic center. We have met the supermassive black hole, Sagittarius A asterisk, the silent, dark anchor of our home. We have seen it as a place of order, of stability, of a strange and profound peace. But there is more to the story. The center of our galaxy is not entirely sleeping. It is a place of hidden energies, of violent memories, of deep and powerful mysteries that we are only just beginning to uncover. Let us drift back now toward that glowing central bulge. But this time, let us see it with different eyes. Not with the eyes of visible light, but with the eyes of high-energy astronomy. With the eyes that can see X-rays and gamma rays. When we look at the galactic center in this light, a different picture emerges. It is not a place of calm, golden light. It is a place of intense and energetic activity. We see great arcing filaments of superheated gas, tracing the powerful magnetic fields near the core. We see the bright, flickering signals of X-ray binaries, where a neutron star or a black hole is feeding on a companion star. We see the diffuse, high-energy glow from countless cosmic rays zipping through the dense central environment. And we see the echoes of the past, the memory of a time when our galaxy's heart was not so quiet. High above and far below the galactic plane, two enormous, ghostly structures have been discovered. They are called the Fermi bubbles. They are two vast, symmetrical lobes of gas that extend for 25,000 light-years in either direction from the galactic center. They are invisible to our eyes, but they glow brightly in the light of gamma rays. What are these giant, ghostly bubbles? They are a shockwave, a cosmic smoke ring. They are the remnant of a colossal explosion that erupted from the galactic center a few million years ago. It was a time when Sagittarius A asterisk was not sleeping, it was awake, and it was feeding a great cloud of gas, or an unfortunate star, wandered too close. And as it was torn apart by the black hole's immense gravity, a huge amount of energy was released, a great blast of radiation, and a powerful jet of high-energy particles erupted from the poles of the black hole and slammed into the gas of the galactic halo. These Fermi bubbles are the scar of that event, the fading, ghostly evidence of our galaxy's violent past. They are a reminder that the heart of our home is a place of immense and untamed power, a power that is currently dormant but not gone. Let this knowledge not disturb your peace, but deepen it. The universe is not always gentle. It is a place of violence and of chaos, as well as a place of beauty and order. And true peace comes not from ignoring the chaos, but from accepting it, from holding it in a state of quiet and compassionate awareness. Can you do that now? Can you hold the image of these great ghostly bubbles, these memories of a violent past, in your mind, and still feel a sense of peace? Can you accept that the heart of your home is both a place of quiet stability and a place of sleeping immense power? This is the peace of acceptance, the peace that comes from saying yes to all of it, the light and the dark, the calm and the storm, the creation and the destruction. And there are other mysteries here. At the center, there is a strange and unexplained glow of gamma rays that seems to have no source. Some have speculated that it could be the faint signal of dark matter particles annihilating each other in the dense environment of the core, a whisper from the invisible. There are great arcing radio filaments that stretch for hundreds of light years, their origin a complete puzzle. There is a sense that we are only scratching the surface, that the galactic center holds secrets that we have not yet even dreamed of asking the right questions for. The spiral arms dance. Our journey now takes us outward once more, away from the energetic and crowded core, and back into the graceful, flowing, and beautiful arms of the galactic disk. We are returning to the place of the great cosmic dance, the dance of the spiral arms. We have learned that these arms are not solid structures. They are patterns, density waves, moving slowly through the disk of the galaxy. But how do these patterns form, and why do they persist for billions of years? This is another of the galaxy's quiet and beautiful secrets. Imagine dropping a stone into a still and quiet pond. Ripples spread outward in a beautiful circular pattern. The water itself is not moving outward. The individual water molecules are mostly just moving up and down. It is the wave, the pattern, the energy that moves across the pond. This is what is happening in our galaxy. The spiral arms are like cosmic ripples. They are waves of higher density, moving through the disk of stars and gas. These waves are likely caused by the gravitational influences of the galaxy's central bar and its companion galaxies, stirring the disk like a great cosmic spoon. As this density wave, this cosmic ripple, passes through a region of the galaxy, it squeezes the clouds of gas and dust. It pushes them together, and this compression is the trigger for star birth. The wave is the creative impulse. It is the signal that it is time for new stars to be born. This is why the spiral arms are so bright. They are illuminated by the brilliant, hot, young blue stars that have just been created by the passing of the wave. These young stars do not live for very long. They are born in the arm. They shine brightly as they travel through it, and then they fade or explode long before they have had a chance to move out of the arm. But the arm itself, the pattern, the wave, continues on. It is a self-perpetuating and beautiful piece of cosmic choreography. Let us float now. Within one of these graceful, curving arms, we are surrounded by the signs of youth and creation. The bright blue stars, the glowing pink nebulae, the dark, dense clouds of gas and dust that are the seeds of future suns. There is a sense of energy here, a sense of life, a sense of becoming. It is a beautiful and hopeful place to be. And feel the motion, not just the circular motion of the galaxy's rotation, but the gentle inward and outward drift as the stars and gas move through the spiral arm. We are not fixed in this arm, we are just passing through. Our Sunday is currently drifting through the Orion Spur, a smaller arm segment. In a few million years, we will have passed out of it and into the darker space between the arms. And then, in a few tens of millions of years, we will enter the next great spiral arm, the Perseus Arm, and be surrounded once more by the brilliant light of a new stellar neighborhood. This is the dance, a slow and graceful movement in and out of the cosmic waves of creation. It is a rhythm of light and shadow, of bright, creative periods, and quiet, restful periods. Does this rhythm feel familiar? It is the rhythm of our own lives. We have times of great creativity, of intense activity, when we are in the flow, when we are in the spiral arm, and we have times of quiet, of rest, of integration, when we are in the space between. Both are necessary, both are beautiful, both are part of the dance. Let the gentle, wave-like motion of the spiral arms be a source of deep peace for you. It is a reminder that life is not a constant state. It is a flow, a rhythm, a dance, and there is no need to cling to the bright moments or to fear the quiet ones. They are all part of the same beautiful cosmic choreography. The local bubble. Our journey has been vast. We have explored the galaxy on its grandest scales, the disk, the halo, the core, the arms. But now, we are going to zoom in, all the way in, to our own immediate cosmic neighborhood, to the special and protected place that our sun calls home. We have learned that the space between the stars, the interstellar medium, is a complex and dynamic place. It is filled with clouds of gas and dust, some cold and dense, some hot and diffuse, and our solar system is currently drifting through a very special part of this medium, a part that we call the local bubble. Imagine that a series of powerful explosions happened long ago near our current position in the galaxy. A cluster of massive stars all reached the end of their lives and exploded as supernovae, one after another, over a period of millions of years. These explosions were incredibly powerful. Their shock waves expanded outward like great cosmic tsunamis. They swept through the interstellar medium, pushing aside the gas and dust. Like a snowplow clearing a road, they carved out a great empty cavity in the surrounding space. And we live inside that cavity. Our Sunday is currently drifting through this bubble of hot, low-density gas that was created by those ancient, long-dead stars. The local bubble is our home within a home. It is a vast structure, about 1,000 light-years across, and it is a place of relative emptiness. The gas here is 1,000,000 times less dense than the air you breathe, and about 10 times less dense than the average interstellar medium. We are in a clearing in the cosmic forest. Let the feeling of being in this special, protected space fill you with a sense of deep security. It is a quiet harbor in the bustling and sometimes chaotic environment of the galaxy. The dense, cold clouds, the turbulent star-forming regions are all outside our bubble. We are, for a time, in a place of peace. This bubble is not permanent. In a few million years, our sun's journey will carry us out of the local bubble and into a denser region of space, perhaps a great molecular cloud or the edge of a spiral arm. But for now, for this moment in cosmic time, we are sheltered. There is a profound gratitude that can arise from this knowledge, a gratitude for the unseen and often accidental circumstances that protect us. The ancient stars that exploded to create our bubble did not do so with any intention of creating a safe space for a future solar system, and yet their violent deaths created a cradle for our existence. This is the way of the universe. It is a place of interconnectedness, of cause and effect, that stretches across billions of years and thousands of light years. The actions of long-dead stars have shaped the environment that you are resting in right now. Feel that sense of gratitude, a quiet, gentle appreciation for the safe harbor in which you find yourself, a gratitude for the cosmic coincidences and the ancient histories that have allowed for this moment of peace, for this moment of life. And this bubble is not entirely empty. It is filled with a very hot, tenuous gas, about 1,000,000 degrees. But the gas is so thin that you would not feel its heat. It is a gentle and almost imperceptible presence. And within this bubble, our sun is a protective parent. It has its own smaller bubble called the heliosphere. The solar wind, the stream of particles flowing from our Sunday, pushes back against the interstellar medium, creating another layer of protection for our Earth and for us. We are in a bubble, within a bubble, a Russian doll of cosmic protection, a series of safe harbors that allow for the delicate and beautiful flourishing of life. The cosmic recycling. The galaxy is a closed system on the grandest scale, a vast and remarkably efficient ecosystem that constantly recycles its own substance. Nothing within it is ever truly lost. It is only transformed. The story of the Milky Way is the story of this eternal cycle of matter and energy, a process of cosmic recycling that drives the evolution of the galaxy and makes the existence of stars, planets, and life possible. This cycle can be understood as a galactic metabolism. The primary components are the stars and the interstellar medium, the diffuse gas and dust that fills the space between them. The cycle begins in the cold, dense molecular clouds of the interstellar medium. These clouds are the galaxy's reservoirs of raw material. Under the persistent influence of gravity, they collapse to form new stars and planetary systems. Once born, a star begins its long life of converting simple elements into more complex ones through nuclear fusion. In the fiery heart of a star, hydrogen is fused into helium, helium into carbon, and so on, up the periodic table. The star is a cosmic factory, manufacturing the heavy elements that are essential for the formation of rocky planets and the chemistry of life. For billions of years, these elements are locked away within the star. The next phase of the cycle occurs when the star dies. The method of death and the way the star returns its substance to the galaxy depends on its mass. A low-mass star like our Sun ends its life in a relatively gentle fashion. It sheds its outer layers to form a beautiful, glowing planetary nebula. This process releases the carbon, nitrogen, and oxygen forged in its core back into the interstellar medium. It is a slow and graceful enrichment of the cosmic environment. A high-mass star, on the other hand, ends its life in a supernova, one of the most violent events in the universe. In this cataclysmic explosion, the star not only releases the elements it created during its lifetime, but the immense energy of the explosion itself forges all the elements heavier than iron, such as gold, platinum, and uranium. The supernova blasts these heavy elements far out into space, seeding the surrounding interstellar medium with the full spectrum of chemical complexity. This returned material, the ashes of dead stars, then mixes with the existing gas and dust of the interstellar medium. The chemical composition of the galaxy is not static. It evolves over time. Each generation of stars enriches the raw material for the next. The first stars in the universe were made of almost pure hydrogen and helium. Our Sun, born billions of years later, is a metal-rich star containing about 2% heavy elements. This is a direct result of the cosmic recycling that has been taking place for over 13 billion years. This process is not confined to the flat plane of the galactic disk. There is a grander, three-dimensional circulation at work, a phenomenon known as the galactic fountain. Supernova explosions, especially when they occur in clusters, can create vast, expanding superbubbles of hot gas. These bubbles are so energetic that they can break out of the thin galactic disk, rising tens of thousands of light years into the galactic halo. They are like great geysers, spewing a fountain of hot, metal-enriched gas out of the plane of the galaxy. This hot gas does not simply escape. As it rises into the halo, it expands, cools, and is pulled back by the galaxy's gravity. It then begins to rain back down onto the galactic disk, a slow, gentle, and continuous drizzle of cooled, recycled gas. This process can take millions of years, but it is a crucial part of the galaxy's metabolism. It redistributes heavy elements, and it brings fresh, cooled gas back to the disk, where it can fuel the next generation of star formation. The galactic fountain model helps to explain the observed chemical consistency of the interstellar medium across different regions of the disk. It is a galaxy-wide circulation system, ensuring that the life-giving products of stellar evolution are shared and distributed, rather than being locked away in isolated pockets. This entire cycle, from interstellar gas to stars and back to the interstellar medium, is the engine of galactic evolution. It is what allows the galaxy to sustain star formation over billions of years. It is what drives the increasing chemical complexity of the cosmos, and it is, ultimately, what makes our own existence possible. The iron in our blood, the calcium in our bones, the carbon in our DNA, every heavy atom in our bodies was forged in the heart of a star, ejected into the galaxy in a stellar death, and then participated in this great cycle of cosmic recycling for eons, before coming together to form our planet, our ecosystem, and ourselves. Understanding this cycle provides a profound perspective on our place in the universe. It reveals a cosmos that is not static or decaying, but one that is constantly renewing itself, constantly transforming death into the raw material for new life. It is a universe of resilience, of transformation, and of a deep and beautiful interconnectedness. The future explorers. Humanity is a species defined by exploration. From the earliest migrations out of Africa to the crossing of the great oceans and the first steps on another world, the drive to journey into the unknown is a fundamental aspect of our nature. For all of our history, this exploration has been confined to our home planet and its immediate celestial neighborhood. But as we look to the distant future, the ultimate frontier beckons, the galaxy itself. The challenges of interstellar travel are immense, dwarfing any exploratory endeavor we have ever undertaken. The distances are almost beyond comprehension. Our nearest stellar neighbor, Proxima Centauri, is over 4 light-years away, more than 40 trillion kilometers. With our current technology, a journey to this nearest star would take tens of thousands of years. Therefore, any realistic vision of humanity's expansion into the galaxy must be one of incredible patience and multi-generational commitment. The concept of the generation ship emerges from this necessity. These are not the sleek, faster-than-light vessels of science fiction, but vast, self-contained worlds designed to support a human population for centuries or millennia as they traverse the dark void between the stars. A generation ship would be a marvel of engineering, a closed-loop ecosystem in miniature. It would need to recycle all of its air, water, and waste. It would need to grow its own food, likely in vast hydroponic or aeroponic farms. It would need a robust and reliable source of power, perhaps a fusion reactor, to sustain it for thousands of years. And it would need to be large enough to support a genetically diverse and socially stable human population. The psychological and sociological challenges would be as great as the technological ones. The inhabitants of a generation ship would be born on a journey they did not choose, to a destination they will never see. Their children's children's children might be the ones to finally arrive. They would live their entire lives in a constructed world, their only view of the outside universe, a starfield of unchanging, distant points of light. Their culture, their society, and their very sense of identity would be shaped by this unique and isolated existence. The first such journeys would likely be aimed at the nearest potentially habitable exoplanets. These are worlds that orbit other stars in the Goldilocks zone, where conditions might be right for liquid water to exist on their surface. Our current and future telescopes, like the James Webb Space Telescope, are beginning to study the atmospheres of these worlds, searching for the chemical biosignatures that might indicate the presence of life. The arrival of a generation ship at its destination would be a moment of unparalleled significance. After thousands of years of travel, humanity would set foot on a new world, a second Genesis. The challenges would be immense. The new planet's gravity, atmosphere, and biology would all be alien. The colonists would need to adapt, to learn, and to build a new civilization from the ground up, all while carrying the legacy of their long journey and their distant home world, Earth. Over the vast timescales of galactic evolution, such a process could, in theory, lead to a slow, patient diaspora of humanity into the Milky Way. A successful colony around one star could, after a few thousand years, launch its own generation ships to other nearby stars. It would be a slow, creeping expansion, a wave of life spreading from one stellar island to the next. Over millions of years, a significant portion of the galaxy could, in principle, be settled in this way. This vision of the future is, of course, highly speculative. It depends on our ability to overcome immense technological hurdles, to maintain social stability over millennia, and to survive the unforeseen dangers of interstellar space. It also assumes that the drive to explore will remain a powerful motivator for our descendants. But the dream of becoming a galactic species is a powerful one. It speaks to a deep human longing for continuation, for transcendence, and for a connection to the larger cosmos. It reframes our own existence not as an end in itself, but as a single link in a great, unbroken chain of life that stretches from the primordial oceans of Earth to the far-flung worlds of other stars. This long view of human destiny provides a unique context for our present moment. It underscores the preciousness of our home world, the only starting point for any such future journey. And it highlights the importance of the knowledge we are gathering now, the maps of the stars, the understanding of exoplanets, the science of closed-loop ecosystems as the foundational work for the future explorers who may one day carry the seed of humanity into the vast and waiting galaxy. The silence and the sound. The common perception of space is one of profound and absolute silence. Because it is a near-perfect vacuum, sound, as we experience it, a pressure wave traveling through a medium like air, cannot propagate. The most violent cosmic events, such as a supernova explosion, would occur in complete silence to a nearby observer. However, to say that the universe is silent is to misunderstand the nature of information. The cosmos is, in fact, filled with a rich and complex symphony of signals, a different kind of music that can be perceived not with our ears, but with the instruments of modern astronomy. This cosmic symphony is played in the language of the electromagnetic spectrum. By building telescopes and detectors sensitive to different frequencies of light, from low-energy radio waves to high-energy gamma rays, we can listen to the universe and uncover the processes that are hidden from our limited sense of sight. This practice, known as multi-messenger astronomy, is revealing a universe that is anything but silent. If we tune our instruments to the radio frequency of 1,420 megahertz, we can hear the faint, pervasive hiss of neutral hydrogen gas. This is the most abundant element in the universe, and its characteristic emission allows us to map the great, cold, dark clouds of gas that drift in the interstellar medium. This is the sound of the galaxy's raw material, the substance from which future stars will be born. It is the deep, quiet, foundational hum of the cosmos. A more dramatic sound comes from pulsars. These are rapidly rotating neutron stars, the incredibly dense remnants of massive stars that have exploded as supernovae. A pulsar emits a beam of radiation from its magnetic poles, and as the star spins, this beam sweeps through space like a lighthouse. If the beam happens to sweep across the Earth, our radio telescopes detect a regular, repeating pulse. Some pulsars spin hundreds of times per second, creating a rhythm of astonishing precision. They are the galaxy's metronomes, cosmic clocks so accurate that they rival our best atomic clocks on Earth. Listening to the beat of a pulsar is listening to the heartbeat of a dead star, a testament to the enduring order that can emerge from even the most chaotic events. We can also translate other forms of astronomical data into sound, a process called sonification. This allows us to perceive patterns in the data that might not be obvious from a visual graph. For example, the light curve of a variable star, a star that rhythmically brightens and dims, can be translated into a slow, rising and falling tone. This is the sound of a star breathing, a slow, patient, and cosmic respiration. The most profound new sounds in the cosmic symphony come from gravitational waves. These are ripples in the very fabric of space-time, predicted by Einstein's theory of general relativity. They are generated by the most violent events in the universe, such as the collision and merger of two black holes or two neutron stars. When these waves pass through the Earth, they stretch and squeeze space-time by an infinitesimal amount. In 2015, the LIGO Observatory made the first direct detection of these waves, opening a completely new window onto the universe. The signal from a black hole merger, when translated into the human hearing range, is a distinctive chirp. It starts as a low-frequency hum, and in the final fraction of a second before the merger, it rapidly rises in pitch and amplitude before abruptly cutting off. This is the sound of space-time itself ringing like a bell, a sound that has traveled for millions or billions of years to reach us. It is the most direct evidence we have of the dynamic and almost living nature of the fabric of the cosmos. If we were to combine all of these signals, the hiss of the hydrogen, the beat of the pulsars, the breath of the variable stars, the chirp of the merging black holes, the sweeping melodies of the spiral arms, and the deep, foundational bass note of the supermassive black hole at the galactic center, we would have a symphony of incredible complexity and beauty. It is a music composed not by a single intelligence, but by the emergent and harmonious interplay of all the laws of physics acting on all the matter and energy in the galaxy. This perspective transforms our understanding of the cosmos. It is not a silent, empty, and sterile place. It is a place of constant communication, of intricate rhythms, and of a deep and resonant harmony. It reveals that our own existence, our own consciousness, and our own ability to create and appreciate music are not an anomaly, but a natural expression of a universe that is, itself, profoundly musical. We are not just listeners to the cosmic symphony, we are a part of the orchestra, the galactic ecosystem. To comprehend the Milky Way is to view it not as a static collection of objects, but as a single, vast, and interconnected ecosystem. Like a terrestrial ecosystem, the galaxy is characterized by a complex web of relationships, a constant flow of energy, and the cyclical movement of matter. Every component, from the smallest dust grain to the largest star cluster, plays a role in the function and evolution of the whole. The principles of ecology it turns in apply on a cosmic scale. The producers in this ecosystem are the stars. Through the process of nuclear fusion, they convert the simplest element, hydrogen, into a vast array of heavier elements. They are the factories that generate the chemical richness of the galaxy, and they are the primary source of the energy, in the form of light and heat, that drives many of the galaxy's processes. The consumers are the various astrophysical phenomena that are powered by the energy of stars. Planetary systems, for example, are born from the leftover material of a star's formation and are warmed and illuminated by its light. Life itself, on a planet like Earth, is a secondary consumer, deriving its energy from the light of its parent star through photosynthesis. The decomposers are the agents of stellar death. Planetary nebulae and supernova explosions are the galactic equivalent of decay. They break down the complex structures of stars and return their constituent matter to the interstellar medium. This process of decomposition is not an end, but a vital step in the cycle of renewal. It is the mechanism by which the heavy elements forged in stars are released and made available for the next generation. The interstellar medium itself can be thought of as the soil of the galactic ecosystem. It is the reservoir of raw materials from which new stars are born, and it is the repository for the enriched material from those that have died. Its composition and density are constantly changing, shaped by the feedback from the stars that live within it. The stellar winds and radiation from young, massive stars can heat and ionize the surrounding gas, while supernova shockwaves can compress it, triggering new waves of star formation. This is a classic ecological feedback loop, where the organisms, the stars, actively modify their own environment. Energy flows through this ecosystem in a complex and fascinating way. The primary energy source is the conversion of mass into energy in stellar cores, as described by Einstein's famous equation, E equals mc squared. This energy travels out into the galaxy as electromagnetic radiation, but other forms of energy are also at play. The kinetic energy of supernova explosions, the gravitational potential energy of gas clouds, and the rotational energy of the galactic disk all contribute to the dynamic nature of the system. This ecological perspective also provides a new way to think about our own place in the cosmos. Humanity is not separate from the galactic ecosystem. We are an emergent property of it. We are a product of its long history of chemical enrichment and cosmic recycling. The very atoms that make up our bodies, our planet, and our technology were all participants in this great galactic ecosystem for billions of years before we existed. Furthermore, as a technologically advanced species, we are beginning to become an active agent within this ecosystem. Our radio signals are a new, albeit faint, component of the galaxy's electromagnetic symphony. Our space probes are tiny, artificial additions to the population of objects orbiting the Sunday. And in the distant future, if humanity succeeds in becoming a spacefaring species, we will begin to consciously interact with and modify our cosmic environment on a much larger scale. This carries with it a profound responsibility. Just as we have learned, often through painful experience, that we must be careful stewards of our planetary ecosystem, so too must we consider our role as future stewards of our galactic one. The long-term survival of humanity may depend on our ability to understand and live in harmony with the great and ancient ecological principles of the cosmos. Viewing the galaxy as an ecosystem transforms it from a collection of distant, abstract objects into a single, living, and interconnected entity. It reveals a universe that is not just beautiful, but also deeply relational. It is a universe where nothing exists in isolation, and where the story of the whole is written in the intricate and beautiful dance of all its parts. The galactic bar. For many years, the Milky Way was envisioned as a classic spiral galaxy, a grand, symmetrical pinwheel of stars and gas. However, modern observations across various wavelengths of light have revealed a more complex and interesting structure at its heart. Our galaxy is not a simple spiral. It is a barred spiral galaxy. This means that its core is not a spherical bulge of stars, but an elongated, bar-shaped structure, from the ends of which the great spiral arms emerge. The galactic bar is a colossal feature. It is estimated to be about 27,000 light-years in length, and it is oriented at an angle of about 45 degrees relative to the line of sight from the Sun to the galactic center. It is a dense and gravitationally dominant structure, composed primarily of old red stars. It is, in essence, a river of stars, flowing in a coherent and organized pattern within the chaotic environment of the galaxy's core. The existence of this bar has profound implications for the dynamics and evolution of the entire galaxy. It is not a static feature, but a dynamic one, rotating as a solid body. This rotation is slower than the orbital speed of the stars in the inner disk, and this difference in speed creates a powerful gravitational influence. The bar acts as a great cosmic stirrer, funneling gas and dust from the inner parts of the galaxy toward the central region. This funneling mechanism is a key driver of activity at the galactic center. The gas that is channeled inward by the bar provides the fuel for star formation in the dense, central molecular zone. It is also the likely source of the material that occasionally feeds the supermassive black hole, Sagittarius A*, triggering the kind of energetic outbursts that created the Fermi bubbles. The bar, therefore, acts as the galaxy's plumbing system, connecting the vast reservoirs of gas in the disk to the engine at the core. The bar also plays a crucial role in shaping the spiral arms themselves. The gravitational perturbations from the rotating bar are thought to be the primary driver of the density waves that create the spiral pattern. The ends of the bar are the points where the spiral arms are born, the places where the gravitational influence is strongest and the compression of gas is most intense. The bar is the choreographer of the galaxy's grand spiral dance. The stars within the bar do not move in simple, circular orbits. Instead, they follow complex, elongated, and highly resonant orbits that allow them to maintain their position within the rotating bar structure. It is a beautiful and intricate piece of celestial mechanics, a self-sustaining pattern of stellar motion on a galactic scale. Observing the bar from our position within the galactic disk is a significant challenge. It is hidden from our view in visible light by the dense clouds of interstellar dust that lie between us and the galactic center. Astronomers must rely on other wavelengths of light, such as infrared and radio, which can penetrate the dust. By mapping the positions and motions of stars in these wavelengths, they have been able to piece together the size, shape, and orientation of this great central structure. The discovery of the galactic bar is a relatively recent development in our understanding of the Milky Way, and it highlights a key theme in modern astronomy. Our galaxy is not an idealized textbook object. It is a complex and messy and dynamic place with a unique history and a unique structure. It is a reminder that our cosmic home is full of surprises and that there are still fundamental discoveries to be made about the very galaxy we inhabit. The galactic bar is a key piece of the puzzle in understanding the overall evolution of the Milky Way. It is a long-lived feature, and its presence has shaped the distribution of stars, the rate of star formation, and the overall morphology of our galaxy for billions of years. It is a testament to the fact that on a galactic scale, gravity can create not just spheres and disks, but also complex and beautiful and dynamically important structures like this great central river of stars, stellar streams. The Milky Way's gravitational field is a realm of immense power and influence, shaping the structure of our galaxy and governing the motion of its stars. But its reach extends far beyond the visible disk, into the vast and dark halo that surrounds it. Here, in this galactic wilderness, we find dramatic evidence of the Milky Way's gravitational dominance, the stellar streams. These are the ghostly remnants of smaller galaxies and globular clusters that have been torn apart by the immense tidal forces of our home galaxy. A stellar stream is a long, thin, and often arcing ribbon of stars, all moving together on a similar orbit through the galactic halo. They are the breadcrumb trails of cosmic collisions, the final, stretched-out vestiges of a once compact object. They are, in essence, the fossils of the Milky Way's galactic cannibalism, a record of the countless smaller systems it has consumed over its 13 billion-year history. The process that creates these streams is known as tidal disruption. When a smaller object, such as a dwarf galaxy or a globular cluster, gets too close to the massive Milky Way, the gravitational pull on the near side of the object is significantly stronger than the pull on the far side. This difference in force, the tidal force, stretches the object along the line of sight to the Milky Way. Over many orbits, this stretching effect becomes so extreme that the object is pulled apart completely, its stars spilling out into two long tails, one that leads the original orbit and one that trails it. These tails then continue to orbit the galaxy, slowly dispersing over time, but maintaining their coherence as a stellar stream for billions of years. These streams are incredibly faint and difficult to detect. They are hidden within the vast and overwhelming sea of stars that make up the Milky Way. Discovering them requires meticulous and large-scale astronomical surveys, such as the Sloan Digital Sky Survey and the Gaia mission. These surveys map the positions, brightness, and motions of billions of stars. By searching for groups of stars that share a common motion and chemical composition, astronomers can identify these ghostly rivers of stars against the bright backdrop of the galaxy. Dozens of such streams have now been discovered, each with its own name and its own story. The Sagittarius stream is one of the largest and most dramatic, a vast looping ribbon of stars that wraps around the entire galaxy. It is the remnant of the Sagittarius dwarf spheroidal galaxy, a small galaxy that is currently in the process of being torn apart and absorbed by the Milky Way. We are witnessing this act of galactic cannibalism in real time. Other streams, like the Palomar 5 stream, are the remnants of globular clusters. Palomar 5 is an ancient globular cluster that is visibly bleeding its stars out into two long, faint tails. It is a snapshot of a globular cluster in its death throes, a beautiful and poignant example of the relentless power of galactic tides. These stellar streams are not just beautiful and ghostly celestial objects, they are also powerful scientific tools. They are probes of the galaxy's gravitational field. By studying the precise shape and motion of a stellar stream, astronomers can map the distribution of mass in the galaxy, including the parts that we cannot see. Stellar streams provide some of the most compelling evidence for the existence of the vast, invisible halo of dark matter that surrounds the Milky Way. The orbits of these streams are shaped by the gravity of this dark matter, and their properties allow us to weigh the galaxy and determine its total mass. Furthermore, the chemical composition of the stars in a stream tells us about the nature of the object that was destroyed to create it. By analyzing the light from these stars, we can determine their age and their metallicity, the proportion of heavy elements they contain. This allows us to reconstruct the history of the Milky Way's formation, a process known as galactic archaeology. The stellar streams are the broken pieces of the smaller galaxies that merge to form our own, and by studying these pieces, we can understand the properties of the building blocks that made our home. The existence of stellar streams confirms a key prediction of our modern cosmological model, that large galaxies, like the Milky Way, grew to their present size through a hierarchical process of mergers and acquisitions. They were not born fully formed, but were built up over billions of years by consuming their smaller neighbors. The stellar streams are the scars of this long and violent and creative history. They are a beautiful and ghostly reminder that our galaxy is not an island, but a continent, built from the wreckage of countless other